a very important problem of pair of straight line, and the problem is prove that two straight lines represented by the equation ax to the power 4 plus bx cube y plus cx square y square plus dxy cube plus ey to the power 4, this is equal to 0, will be equally inclined to the axis of x if this condition be satisfied. Okay, and clearly the given equation must passes through the origin. Okay, so we let y this is equal to mx be any one of the four straight line of the given equation. Okay, we here say four straight line because the given equation is a biquadratic equation of or homogeneous equation biquadratic of x and y. Okay, now we put the value y this is equal to mx in the given equation, and we can write this equation as e m to the power 4 plus d m cube plus c m square plus b m plus a, this is equal to 0, and here we cancel out from both sides x to the power 4, since x to the power 4 is a variable, this is not equal to 0, and since this is a biquadratic equation of m, so it has 4 root or 4 value of m we get from this equation. Let these are m1, m2, m3 and m4. Now write the relation between roots and coefficient of the equation. We get m1 plus m2 plus m3 plus m4, this is equal to minus d by e. Okay, and the second relation we can write this is m1 plus m2 into m3 plus m4 plus m1 m2 plus m3 m4, this is equal to c by e. Okay, and the third equation is given by m1 m2 into m3 plus m4 plus m3 m4 into m1 plus m2, and this is given by minus b by e. Okay, and the last relation is m1 m2 m3 m4, this is equal to a by e. Okay, we get 4 relation between roots and coefficient. Now since it is given that two of the straight line represented by this equation makes equal angle to the x-axis, and we draw a rough sketch, this is x-axis. If these two straight line makes equal angle with the x-axis, so this angle is theta and this angle obviously minus theta. So if the slope y this is equal to mx, and it must be y this is equal to minus mx. Okay, so we get these two straight lines are y this is equal to m1x and y this is equal to m2x. Hence we must have m1 this is equal to minus m2, that is m1 plus m2 this is equal to 0. We get this is from given condition. Okay, now putting the value of m1 plus m2 this is equal to 0, we get the 4 relation becomes, the first relation is m3 plus m4, this is equal to minus d by e. Second relation is m1 m2 plus m3 m4, this is equal to minus c by e, and the third relation is this is 0, so this is m1 m2 into m3 plus m4, this is equal to minus b by e, and the last relation we get, this is given by putting the value of this here, we get first this is m1 m2 into minus d by e this is equal to minus b by e. So we get m1 m2, this is equal to plus b by d. Okay, now from the last relation we get, by putting the value of m1 m2 here, we get m3 m4, this is equal to a by e into d by d. Okay, so we get m3 m4 and m1 m2 also. We putting both the value here, we get the relation as minus, sorry, this is not minus, this is b by d plus this is ad by eb, and the right side is minus c by e. Okay, and taking LCM here, e b d, and this is b square e plus this is a d square, and the right side is minus c by e. So we get b square e plus a d square plus this is c b d, c b d, this is equal to 0. Sorry, this is not our required proof. We make some small mistake here. This is not minus, this is plus. Okay, this is plus, so this is plus, and we get this is plus, and this is on the right side, and this is our required proof. B square c plus a d square plus b square e, this is equal to b c. Okay, very interesting problem of pair of straight line. Thank you for watching.